Today we're talking about the interior and exterior angles of polygons. When we're talking about the interior angles of polygons, the angles that are inside of them, if we want to find the sum of the interior angles, what we want to do is divide each polygon into triangles, because we know that the sum of interior angles of a triangle is 180 degrees. So since we know that about triangles, could we figure it out for quadrilaterals? Sure, because any quadrilateral is really just two triangles. To see that, connect two vertices diagonally. Then you'll have 180 degrees and 180 degrees for a total of 360 degrees. How about the pentagon? Well, I'm going to start at one vertex and connect to another vertex diagonally and to another one diagonally. And that's all the diagonals I can draw from that vertex. So I have three triangles here, and each of those triangles has a sum of interior angles of 180 degrees. Well, 180 times 3 is 540 degrees. What do you predict will be the sum of interior angles for the hexagon? Well, we have four triangles this time, for a total of 720 degrees. So one thing I want to point out really quick is that when we draw our diagonals, we don't draw to the to the vertices that are right next to the vertex we start from. Did you notice there's always two vertices that get left out? So for our quadrilateral, we didn't draw four triangles. Instead, we drew 4 minus 2 triangles. For our pentagon, we didn't draw 5 triangles. Instead, we drew 5 minus 2 triangles. And for our hexagon, we didn't draw 6 triangles. Instead, we drew 6 minus 2 triangles. The triangle was just one triangle. The quadrilateral had 2, the pentagon had 3, the hexagon had 4. Well, what if we had n number of sides? What if we had n sides? Well, there'd be those two vertices that we couldn't connect to, right? Because they were already connected to the vertex. So we would have n minus 2 triangles. And we calculated the sum of interior angles by multiplying the number of triangles by 180. So if I wanted to write an expression for that, I would just write n minus 2 times 180. Okay, so let me clear up my polygons on top again. Now that we know the sum of interior angles for each of these polygons, we can figure out the measure of each angle if they are regular polygons. So I'm going to go ahead and draw some tick marks showing that these are regular polygons. And now we can use the sum of interior angles that we found earlier to find the measure of each angle. Well, for the triangle, there's 3 angles, and together they sum to 180 degrees. 180 divided by 3 is 60 degrees. So each angle has a measure of 60 degrees. For the quadrilateral, 360 should be divided by 4 because there's 4 angles. So that means each one measures 90 degrees. In this case, they're each right angles, and that's a square. For the pentagon, we have 540 divided by 5, and that's going to come out to 108 degrees. So each of those angles has a measure of 108 degrees. And for the hexagon, we divide 720 by 6, arriving at 120 degrees as the measure of each angle of the hexagon. Now remember, these measurements are only true if they are regular polygons, meaning all the angles are congruent and all the sides are congruent. Even if they're not regular polygons, however, the sum of the interior angles will stay the same. All quadrilaterals, even irregular quadrilaterals, have a sum of interior angles equal to 360 degrees. And all triangles, no matter what they look like, have a sum of interior angles equal to 180 degrees. The sum of interior angles will be true for these polygons, no matter whether they're regular or irregular. The measure of each angle of a regular polygon only holds true, however, when we're talking about a regular polygon. So back to regular polygons, could we write an expression for the measure of each angle of a regular polygon? Sure we can. We just need to take our sum of interior angles and divide it by n. So when we divide by n, we'll end up with n minus 2 multiplied by 180 over n. So now we know our key formulas for interior angles. The sum of the measures of the interior angles of any polygon will equal n minus 2 multiplied by 180. For a regular polygon, the measure of each angle will equal n minus 2 times 180 divided by n. Now, we haven't talked about exterior angles yet, but what you need to know about the exterior angles is that the sum of the measures of the exterior angles is always 360 degrees. There's always 360 degrees around the outside of a polygon. We've got our formulas. Let's use it to solve some problems. So here we have a hexagon, and we want to figure out what x is. This hexagon is not drawn to scale. I can tell because clearly the angle measures are different, yet it looks like they are the same in the picture. So just be aware of that. Now I know how many degrees a hexagon has in its interior. I just do n minus 2 times 180. N represents the number of sides, so that's 6 minus 2 times 180. 4 times 180 gives us 720 degrees in the interior, just like in our table that we just created before. So if I add all of these expressions together, I should get 720. Whew, that's a long equation. It's an easy equation, but it's pretty long. Let's see, I've got 6 x's. There they are. Now let me add up my constants. And you know what? They actually, when you put them all together, add up to 0. So 6x plus 0 equals 720. I could actually just write 6x equals 720. And dividing both sides by 6, I find that x is equal to 120. We did it. Now, if I wanted, I could even find the measure of each angle since I know what x is. Let's see, 120 minus 4 is 116. 120 minus 6 is 114. 120 plus 10 is 130. 120 minus 5 is 125. 120 plus 3 is 123. And 120 plus 2 is 122. What do you think we would get if we added these all together? We would get 720 degrees. Well, I hope you're feeling smart. Now let's see if we can solve for x in this next problem. These are exterior angles. They're on the outside of my polygon. And the sum of the exterior angles for any polygon is 360 degrees. So I know that 3x plus 10 plus 2x plus 40 plus 1x plus 10 equals 360. Let's add this all up. Combining like terms, I get that 6x plus 60 equals 360. Subtracting 60 from both sides, I find that 6x is equal to 300. And then dividing both sides by 6 tells me that x is equal to 50. I've answered my problem. I could actually go one step further and find those angle measures. 3 times 50 plus 10 is going to equal 160 degrees. 2 times 50 plus 40 is 140 degrees. And 1 times 50 plus 10 is 60 degrees. If we add those together, we'll get 360 degrees. Our next problem down here is a word problem. It says that the sum of the measures of the interior angles of a polygon equals 620 degrees. How many sides does the polygon have? Well, we'll want to use our formula for the sum of the interior angles of a polygon. That's n minus 2 times 180. So we know that n minus 2 times 180 equals 1,620 degrees. Could we solve for n? Sure we could. There's more than one right way to solve this equation. I'm going to start out by distributing my 180. Then adding 360 to both sides, I end up with 180n equals 1,980. Dividing both sides by 180, I can see that n is equal to 11. So this polygon has 11 sides. Here's a bit of trivia for you. A polygon that has 11 sides is called an undecagon, or a hendecagon. They both mean the same thing, an 11-sided polygon. So in summary, we have a couple of key formulas here. The sum of interior angles of any polygon equals n minus 2 times 180. We could also go one step further if we have a regular polygon and say that each angle would then be equal to n minus 2 times 180 divided by n. Sometimes we get fancy and we use that. The sum of the exterior angles of a polygon is always equal to 360 degrees. So this is the summary of the information that we're using to find the measurements of angles of polygons.